with your contribution, okay? Not just me. So please don't look at papers, except if you have something in your paper to share, all right? Don't look at any other thing. So this graph is for the gradient. We want to try to draw the function that led to this gradient. Clearly, this is a parabola, right? So the gradient function is what? Type of polynomial? A what?
Because this is the gradient.
This is the gradient function. So that's a quadratic, right? So what can you say about the function itself?
Cubic.
It could be cubic. So being cubic, we're going to have 2 points at most. Right? We're going to have 2 stationary points at most. Okay? So, or should I say 2 turning points? Because there's going to be a point of inflection, making the stationary point maybe about 3. Anyways, a point of one plot of inflection might be included. Anyway, you understand what I mean? I think I was mixing it up. All right, so what do we know? Anybody? Share opinion. What do we know? That are facts from here.
You know that A and C are going to be the maximum or minimum.
A and C are the critical points. Okay, that's what it meant. Critical point. A and C are the critical point. Do you understand why I said that? It crosses at A and C. Okay, so if this curve is G, at A and C, G is equal to 0. Right? And for you to say that this is equal to 0, it means that point of X is the critical point. So that we know. So it's probably going to turn here, or it's going to turn here, or like this, we don't know. Understand? So let's take note of that. A and C are critical points. What else? Yes?
B is point of inflection.
B is
Point of inflection.
Why do you say that?
Because for F and then the 2 dashes X, it's going to be 0.
It's going to be 0. B is a stationary point for this curve. Which means at B, so what I try to do is to say let G of X be F prime of X. Maybe that will make it clearer. Okay? At B, let's change the color so we don't mix all this argument together. At B, G prime of X is equal to 0. Which means F prime prime of X is equal to 0. And that means B is a stationary point. What? Oh, it's a point of inflection, sorry. Then B is a point of inflection. But we don't know if it is a point of inflection that is stationary or non-stationary. Yeah, I'm just saying, like for now, okay? But why do you say it's non-stationary? Because it's not 0. Because what is not 0? Because F prime X is not 0 at that point. Remember, if this happens and this is equal to 0, then it's a stationary inflection point. This is equal to 0 means it crosses this axis at that point. It means F prime crosses. Okay? My F prime is my G now. Okay? If this happens and this happens, then it's a stationary point of inflection. Okay? But at B, that's not where this black graph crosses. If this had happened when it crosses here, so maybe we have something like this, or we have something like this, then yes, it's a stationary point of inflection. Does that make sense? So, it's a non-stationary point of inflection, which means it's not one of those that goes like this. It's going to be where the curve changes sign. But we can investigate that in the sign diagram also. Understand? So, any other point from anyone?
If B
Oh,
is
sorry, I write this first. This means B is a stationary, no, a point of inflection. Sorry, 1 minute. The point of inflection, which is non-stationary, because what? Karen? Because f prime x is not equal to 0. Perfect. Okay, yes sir, your point.
We know that B is non-stationary, so it means one's going to be like this, like that, right?
So we can discuss the curvature.
The
Is that what you're saying?
Yeah.
So we can look at the curvature. So if B is non-stationary, it means it changes sign at B. The curve changes sign at B. Then you need to know, before B, was it concave upward or downward? And after B, was it concave upward or downward? That's the next thing we need to investigate. Okay? So I can add here. Okay? At B, we also know, okay, this implies that at B, there is a change in curvature of what? F of x, which is what we are interested in. Okay? So how do we know? We need to now check
We
the
don't
sign.
even need to check though.
What?
I don't
No
think,
need-
because like you can see from A to B, it's like going up, right?
Yeah, but if you have to not just see, you should just put it down. It's just a line.
Like your
Okay? We already know, right? So we just write it down. So at B, what is x at B? We don't know. It's not labeled, right? So we could just call it maybe some x1. Okay? So this is the graph of the second derivative. I will sign diagram for the second derivative. From B, what happens to that gradient? This is the gradient of this curve now, right? So the gradient is what? It's negative. And the gradient here is? So what does that tell you about the curvature before? Is it concave upward or downward?
Upwards.
This is upward. Gradient is positive. So gradient of this positive means the graph goes like this. Right? And gradient negative means graph goes like that. So here we have concave up. So here we have concave up, and here we have concave down. Understand? So I think this is enough information. We know the turning point, we know the inflection point, we know where we have a concave up or down. I think we can sketch. Understand? So let's now sketch our curve. Let's use the red marker. So there's a turning, if this is concave up here, then concave down afterwards. So concave up here means our A is the local minimum point. Right? Our A is the local minimum point. Concave down means, so it's going to go like that. There will be a change here because another journey shape for the shape begins. Then our shape here will be local maximum. Do you understand that? Something like this. Okay? And there will be a change in, so when it goes like that and comes, so somewhere here, or maybe somewhere here, we don't know. There will be a change because the shape is like this, then like that. Alright? So this is the point B now. X at B. Understand that? So let's just sketch. It's a sketch, so it's not going to be perfect. So here, another shape begins. Something like this. Do you understand what I mean? So all you have to do is label. Oh, this doesn't look like a turning point. Let me try to be a little bit. Does it look like it? No. Nakita, I try to use your OCD scale. I guess it's not my talent. So, something like this. Okay, I think this, just manage this, okay? Sorry, I couldn't do what Nakita and Lillian could do. It's you, most OCDs here. And Karen too, I guess. Alright. Okay, so, but what we do not know is, here, is it going to be up or down? We don't have enough information. Okay? So either way, it will be regarded. For those that have done it, did you get the same thing that we just did?
Yes.
Alright. For those that haven't done it, is it clear? Please confirm if what we have said is clear to you. So you label, please. This is y equals f of x. Apart from that, you should label the critical point. Even if the question doesn't tell you to label, you should. So you go like this, okay, and say local minimum point, something like that. Okay, so you label here also point of inflection, non-stationary, right? Point of inflection. And here, so you do this, something like that. Allow me to put it here. Local maximum point. Just label properly. Okay. Of course, you should write your findings away from the axis, so you have space to do your label. Okay, I just try to manage the space on the board. Okay, so when you're doing it, keep all this additional information away from the axis. You do them outside the axis. The current, do you understand what I said? So you have enough space to do all this labeling. Now let's look at this one quickly. So this is the graph of f. We need the graph of f of x, f prime of x, and f prime prime of x. First derivative and second derivative. So what do we know? Anyone? What do we know? I'll try to stay away from that. So let's try to manage the space here. Yes, quickly. First information that we know.
At A and B, f prime x is 0.
Say that again.
At A and B, f prime x is 0.
At A and B, I will draw with red again. So let's use this. At A and B, okay, what happens? F prime of x is equal to 0. Okay? So it means -2 and that is local. So what is the implication of this? Say that again. A and B are the x-intercepts of the graph of the derivative we are looking for, graph of the gradient function. So that is where it crosses the x-axis, okay? So which means y is equal to f prime of x crosses x-axis at x is equal to -2 and x is equal to 8. What else do we know?
The midpoint of -2 and 8 is the
Point of inflection.
Yes.
Do you agree with him? The midpoint of these two, which will be 3, I guess, but we just call it x1. That will be 3, right? From here to here.
Yes.
Okay? So, because your point of inflection will be here. Okay? So I just call it x1.
Yeah, because that's what we
But that's, you remember it's quadratic, right? One part, this would be symmetrical, another one joining, so that's what it meant by that. But just to avoid any form of, just call it x1. Okay, so x1 is our point of inflection. Is it a stationary point of inflection? Or non-stationary?
Non-stationary.
So being non-stationary, what can you say? What 2 facts can you bring out from there?
It's for f prime x, it's not going to be at 0.
Speak louder.
The y value is not going to be at 0. For
No. So give me something like this. That's what I meant. 2 facts like this. For x1. At x1. F prime x is not 0. F prime x not 0. Understand? Then what else? We don't need the second information now, but we can just write it. F prime prime x must be 0 at that point. Okay? At maybe I call that point C now myself. Okay? At C, we know that f prime x must be 0, but f prime x is not 0. Okay? So, since this is not 0, it's another justification that it doesn't cross the x-axis. I think we already know that. Unless it's going to cross 3 times. You're not going to cross here, go back cross here again. But what if that is possible? We don't know, okay? But it is a fact that it doesn't cross. So we now need to investigate if this point is going to be here or here, so that we have this or we have this, we don't know yet. Okay? What fact do we have? What fact do we have? You can look at the increasing and decreasing interval now.
Oh, can you look at that one?
Yeah. Sign diagram.
Yes.
Okay? We can use the sign diagram now. We are looking at f prime of x. That's our what we're investigating now. Between 3 points. Okay? Between 3 points. What are the 3 points? We have x1 also, and we have what? 8. Now, what is the gradient up to 2? Positive, then negative, then negative also, right? Then what? Positive. I think this is clear. It means the gradient being that means that this function we are looking for is above the x-axis in this interval, below within these 2 intervals, and above at this interval. To draw it, you are looking at the shape, right? But to interpret it now, because of the line we are about to draw, you are looking at above or below the axis of x. Does that make sense? So with this, it's clear. We already know, I think this also means something that we haven't mentioned. This is the stationary point of the curve we're about to draw.
Yes.
F prime prime x is equal to 0 means dd of x of f prime x is equal to 0.
That means it's...
So it means that is the stationary point. So the point of inflection of the original curve is a stationary point for the gradient function. So while we know that this is positive and it comes down, it means it turns at x1. That's the point I'm trying to make. Okay? So let's go like that. So it's going to turn somewhere on this line. Hopefully I can draw it once this time. Yay, I did it. My OCD works. So this is the graph of the gradient function. Understand? So the last is the graph, even though it was not asked, but it's needed. That's why I want us to draw it too. If it was not asked, you don't need to draw it, but to answer this question, you might need to eventually. Okay, so let's see. The question is, write down in order, okay? So this one is easy to figure out. This one is easy to figure out because we know the graph, but we don't know this one. F prime prime at 2, it means the graph of this one. So try to draw the graph of this one. So that's why I put it there. Even if it is not there, you should draw it for easy reference. So let's try to draw the graph of the second derivative. I think we can do that by just using the sign diagram, right? Before we do the sign diagram, there is something else we should take note. This fact here. At C, okay? At C, so this is a recall because we mentioned it already, all right? Recall that at C, okay, f prime prime x is equal to 0, which means the x value. What is the x value? x1. We call that x1, right? So it means x1 is where whatever we are trying to draw now crosses the x-axis. Again, what shape would this graph of x second derivative be? Say that?
Linear.
That's not a shape. It's a line. So it's going to be a straight line, isn't it? So a straight line like this, like this, like this. That's what we don't know. Presume we don't know. Let's assume. Okay. So, but we know that it crosses here. Okay? So we just need to know if it crosses here, we need to know after here, is it above or below? That's where your sign diagram now comes in. So, and to do that, we try to look at the graph, the blue graph that we have drawn. Is the gradient positive here or negative? That's positive, right? And this is negative. From here to here is negative. So this is clear. The shape here tells us this. But what does this mean? Just the way we did this one too. What does this mean? The line we are trying to draw is below the axis within this interval and above the axis in this interval. So which means our line now looks like this. Crossing here. So this is the graph of y equals f prime prime of x. Understand? I will write that in red so we can match which one it belongs to which one easily. Does that make sense? So with this, it's easier to answer the last question. In order, let's see. F minus 2, what do we know about it? That is, f minus 2 is positive, right?
Yes.
Can you see that? We don't have a specific value. What about f prime of 8? What do we know about it? F prime of 8?
0.
0. Yes, f prime is the blue line. So what about f prime prime of minus 2? Negative. Is it?
Yes.
Yes.
So now we can write in order, starting from the smallest. So it's going to be what?
F prime prime.
So order is, okay, f prime prime minus 2. I think it's the reverse now.
Yes.
Okay, f prime of 8 followed by f of negative 2. Okay, so that solves that one. Any questions? Okay, so let's quickly take note. If you have not done it, please take it. So I'll just write this one in red ink so we can match it easily. Yes. Yes, please.
That one? Okay. Alright. So, see this graph, right?
Okay.
This is.
So you know that this, okay, the blue one is just to be able to picture that clearly. I'll just solve some questions on Lupita's rule before we go, so that when we are practicing, we have enough information.
If it is,
Or maybe we can look at that tomorrow. Spend the rest of the class starting the problem that I gave you today. Completing your note and starting the problem, and ask me questions so I do not mix it with practice of Lupita's rule. Yes, sir.
correct me if I'm wrong, but if it's a state, but if it's at 0 here, then at the other, like, if it's like above, like if it's f of x, and it touches this, at f of x, it's not going to touch, and at f prime prime of x is also not going to touch. That's what I realized. It's like, look, if you look at this graph, right, this is f, yeah, this is f prime of x. You'll
Yes.
notice that for the f of x, it's not going to touch, and then for f
Touch what?
the x-axis.
Okay.
And then at the f prime prime of x is also not going to touch. And then that's how I usually draw the graphs.
I don't get it. Speak clearly so that maybe we can also learn from that.
Just look here, right? So it's like this, and then we know here from this side that it's going to be a it's going to be like an upwards sloping curve. And it's going to change it here, right? So we know it's going to be like that, and it's going to change.
Are you talking about this one?
Yeah.
So which area, which section are you referring to? So you're talking about this one?
Yeah.
Okay.
It's not going to touch 0.
But it touches here. You're saying it doesn't touch at this point.
Yeah.
Of course, because it's a turning point.
Yes, I'll just like, and then here it's also like, if when it alternates, it's not going to touch.
Where it alternates.
So like at this point, at F prime, since it touches at F prime.
Oh, since this one touches, then this will not touch.
Yes.
Sure. Oh, I see what it means now. Yeah, I think that's one of the things we use even without actually looking at it that way. Because if that makes it easier, if that is the pattern you're looking at, yes, please go ahead. Oh, yes, sir?
So basically, if that's F, F prime of X.
I think I get what it means.
Yeah. If it touches here, it's not going to touch here or here. Because it's going to be that thing. Actually,
Yeah, I think we should turn it off since we're done.